All right, welcome to our next lesson. This one is on growth and decay. So these are going to be exponential functions, specifically ones that are growing, so they're rapidly increasing, or decaying, rapidly decreasing, like we worked on yesterday. So first we're going to start with exponential growth. So you're going to notice I'm kind of taking two parts from that first page of your notes. So it means it's increasing or it's growing over time. Okay? And our equation is going to look something like this. The y is my final amount. That's my answer. A, that number out in front of the parentheses, is the initial amount. What are we starting with? T is going to be my variable up top. That's my input. I'm going to put in an amount of time to calculate how much is it going to grow to over a certain amount of time. And then because this one is a growth, R is the amount of growth. So there's going to be a percentage. It's growing by 3% or 5%. So the key is always that growth part. If it's going up by an amount, so if it's 1 plus something, it's growing, because if I'm multiplying by something larger than 1, the number is going to continue to grow as we get larger. So what it looks like on a graph. So here's my y, and time is going to be my x-axis. It's going to start at some amount. That's my initial amount, A. And it's going to start to grow, but that's going to go faster and faster and faster and faster. And it's going to be that exponential growth where it's going up by a larger and larger amount because that variable is my exponent. My equation might be something like y is equal to a starting amount of 50. It's going to go up by 15%, which is really kind of 0.15. So I'm going to have 1.15 to the t power. So it's increasing at 15% each year. So every time I multiply times another year, it's going up by another 15%. All right, exponential decay. Everything is similar in the equation for exponential decay, except for the r, because it's decaying, it's subtracted from 1. So 1 is 100%. If it just stayed at 1, everything would stay the exact same every year. If it's below 1, now I'm multiplying by something less than 1, meaning my total is going to get smaller and smaller and smaller each year. So in my graph, again, I'm going to start with some amount, A, but over time, instead of going up, it's going to slowly start decreasing faster and faster over time. So it's not changing by the same amount, it's increasing that rate of decay faster and faster as more and more time goes on. As an equation, it's going to look something like this. So maybe we start at 3,000 of something. It's going down by 8%. So that's 0.08. So my number in here is going to be 0.92. So think of 100% and I took away 8%. It's going down by 8% each time. Multiplied times how many years that's going to be, or whatever the time value happens to be. So the key for these problems is going to be this number here. Is it greater than 1? All right, now it's growing. Or is it less than 1? All right, now it's decaying and it's going to be getting smaller. All right, so up top, we kind of have what I was just talking about. If it's growth, your rate is being added to 100% because it's getting bigger and bigger. So you're looking for something that is greater than 100, or in this case, greater than 1, because we want something greater than 100%. If it is decaying, it's going to be subtracted from that 100%. So then we would want something less than 100% or less than 1 in that parentheses there. That's how we decide what it's going to be. So if we look at this first one, in my parentheses, I have 2. That's greater than 1, so that's going to be a growth function. My initial value is that number out front at 3. And then my growth or decay factor is, what did it change by? Well, I've got a 2 in there. So it started at 100%. It went to 200%. So it has a growth factor of 100%. Because 100 plus 100 is 200. which as a decimal is really 2.00. All right, next one. I look inside and I've got 0.3. That's definitely less than 1, less than 100%. So this is going to be a decay function. I don't have a number out front, but remember, whenever there's not a number out there, we really know it was a 1. So it had an initial value of 1. And then how much did it change by? Well, it started at 100%. It went down to 30%, which means it went down by 70%. Because when we changed it into a decimal, that's how we got it into a 0.30. So you have to remember that they're changing these percents into decimals when we plug them into our growth or decay functions. All right, next one. We look in those parentheses. I've got a 0.7, so less than 1. That's going to be decay. My initial value is 3. That was my starting point. And it went from 100% to 70%. Because remember, that's really what 0.70 is. So that means they must have subtracted 30% to get to 0.70. So my decay factor is 30%. All right, last one. Hopefully you picked up on the patterns here for us. So we're going to look in here and I see an 8. That's clearly greater than 1. So this is growth. My initial value is that number out front of 2. And here I went from 100% to 800%. Well, that means they added 700% increase. So it's growing by a huge amount. All right, last little bit. Can we take that information from kind of a larger problem here? It says the Johnson Company calculates the value of its stock each year by using the function y is equal to 120 times 0.98x. So you'll notice in here, immediately you should notice, ooh, it's smaller than 1. It's going down. So this is going to be decay. They're expecting their stock value to decrease each year. The initial value was 120. So that was the value of the initial stock. And 0.98, well, think about 100% to 98%. It went down by 2%. Next one, Selena's starting salary for her new marketing job is $32,000. She calculates her projected salary for the next 5 years by using this function. Y is equal to 32,000 times 1.12 to the x power. Well, I look in those parentheses, it's greater than 1, so that's going to be growth. Because anytime I'm multiplying by something larger than 1, it's going to increase. If I think of 1 as being 100%, 112, or 1.12, it would be an increase of 12%. And my initial value, well, that was her starting salary of $32,000. All right, I kept this one shorter for you, okay, but that'll give you a good introduction to this, and then we'll work on it on Monday.